Hello everyone, I hope everyone is fine, staying safe and staying home. We are Group 11B, Team 1, Bridge Heads, and here's our presentation for our project. To start with, here's a brief summary about bridges and how their idea was developed. Originally, bridges started as an idea for the purpose of crossing valleys, water bodies, and eventually roads, but it was not about the construction of the bridge itself. Based on the function the bridge served, its type was determined. Surprisingly, earliest bridges were naturally made. Humans discovered them and they were simple as logs or naturally collected rock arcs, like the picture in front of us, and were used to cross water streams. An interesting backstory for the origins of the idea of the suspended bridges is that humans observed how monkeys swing from vine to another to get from place to place by twisting and braiding the vines. From this observation, the idea of connecting parallel cables with truss pieces of wood and other materials was created, and there was one of the simplest shapes of man-made bridges. And from there, the idea continued to develop till our current time, and during this period, various types of bridges were created according to the human needs. What are the different types of bridges? There are some types of the bridges. The first bridge in the USA from 1900 AD, and its photo is the first one in the slide. And the bridge in China, made completely from stones, allows boats to pass due to its shallow arc, and the ancient Roman bridge, 100 BC Romans, made from mud and straw.
Hey everyone, my name is Kareem Kassab, and in this part of our presentation, we're going to talk about the Popsicle Annual Competition. First of all, the competition is hosted by the ASCE, which stands for the American Society of Civil Engineering. This society was first professionally founded in 1852, and since then it held its title with expertise and was a major support for the practical activities related to civil engineering, such as bridges, of course. In addition to that, it has organized tons of competitions for high school and college students for the past 25 years. To have a clear image on the contest, we must follow the following procedures. We first start with the design, which must be unique to satisfy the efficiency percentage of the bridge. So it must be lightweight and support heavy weights at the same time. Then we follow up with the most important part of the contest, which is constructing the bridge. The construction part is obviously hard, so it must be done with high accuracy and precision. Last but not least, we finish with the presentation that allows us to impress the judges and be creative. Now I'll leave you with my fellow colleague Hussein, who will talk about the background of the bridges.
Hello everyone. In this section of our presentation, we'll be talking about what drives us to build our own version of the bridge. So it was basically a simulation of a bridge that would need to build in real life for people to pass from one side of the land to the other side, rather than traveling all along the shore to get to the other side, thus saving a lot of time and effort. Of course, such a project would need many features to get the best out of it. One of those features is supports that would be dug deep into the bottom of the lake, so to resist water currents that may be present in the area, creating a more stable bridge. Of course, one of the major requirements of the bridge is supports that are made of a material that is corrosion resistant, such as stainless steel, due to the presence of chromium element, which helps a lot in achieving this function. It also must be as rigid as possible in order to resist the heavy currents that we have talked about in the previous slide. Of course, a balance between cost and quality of the material must be achieved in order to get the least expensive materials with the best quality possible for our bridge. So, why do we simulate? As I've mentioned before, our bridge here is basically a model of a real-life bridge that we need to implement somewhere. So we used our model in order to test if the design will be appropriate using the geometry of the place or not. and whether the supports would be able to withstand a high amount of loads or not. It's also much easier to build a model than to build the whole thing and start correcting for errors in terms of both price and human effort. So we'll save a lot of money using modeling. Of course, sticks was an easy and cheap way of modeling rather than using something like 3D printing, for example. So it helped us a lot in our model. Now I leave you with my colleague Nour, who will talk about how did we manage to get our final model using only sticks and glue. Thank you.
Hello everyone. Now we are going to discuss how we finally did approach our aim after multiple unsuccessful trials. Firstly, few hours passed thinking deeply as a team which is the most suitable, following the rules and efficient design. Puzzled between whether placing the truss above or below the bridge, after searching, it was found that constructing the upper one will be much less complicated. And as advised, a fellow civil engineer's experience had helped in designing most possible efficient supports. Now, let's talk about the bridge's design. Spotting lights on the supports, we had managed to use the minimum number of sticks. Thus, as shown in the picture, it was constructed on a triangular shape. Turning to the truss, the biggest competition was to glue the sticks together accurately with the correct angles. Therefore, this includes holding them together till they dries without any change in the angles. Various shapes of trusses were taken into consideration, but the chosen one was the Warren truss, as it is featured by being a weight-saving truss. Talking about the deck, it was managed to be as much stable as possible using minimal sticks. Any construction has its own sequence. Ours was as follows. We built each part independently. Then we connected them all together. So the roadway was firstly built, then the truss was accurately constructed on the same time other two team members were finalizing the supports. After that, the roadway was inserted into the truss and glued strongly to each other. Then the truss was held on the supports and sticking them to each other accurately. And by that, the whole bridge was successfully assembled. Now, I will leave you with my colleague Basel talking about load transfer and the conclusion.
And now comes my favorite part of the project, the truss. Apparently, it is an essential element of any bridge as it plays a major role in its stability. A question that frequently got into my mind was how would the road be transferred from the roadway to the supports, or even how would the roadway itself stay stable and not break from its own weight. The answer to all of these questions lies in the truss. Basically, the weight of both the roadway and the load applied on it are distributed all over the truss by actions of compressions and tensions of its components. This mechanism consequently makes the bridge a lot more stable as the weight is not concentrated at a single point. Working on this project certainly gave us a myriad of experience and other benefits. To begin with, our engineering experience has dramatically improved, whether it regards the theoretical part, as we understood much more about trusses and bridge mechanics, or the practical part, as not only we became much more aware of the importance of planning before working, but also for the first time in our lives, we had to build something pretty complicated without professional help. It would be a shame not to mention the teamwork. Again, for the first time in our lives, we fathomed the importance of distributing tasks evenly and correctly, keeping in mind the time management. Finally, I hope you're satisfied with our project. I would like to thank my colleagues, those outstanding people who gave their all and left no stone unturned to deliver good results.